Alright, you remember how we got to our basic function, y equals a to the x, but now we're going to be moving it around. We're going to use our transformations to do some graphing too. So, check out this function, y equals 4 to the x minus 1. I know that's kind of tiny. X minus 1 is in the exponent. So remember our basic parent function would have been 4 to the x. So what's the transformation? Well, there's a minus 1 involved. Is it inside or outside the function? It's inside. They put the minus 1 in the exponent there. So which direction is it going to go? It's going to go to the right. Okay? Now, it's been a while since we've done this, but what happens is we move the origin for the left, right, or up, down transformations. So I'm going to move it to the right one, and we're going to call this 0, 0. Okay? Now, do you remember that we had 3 very important points? Now that we've moved it to the right one, we're just looking at the function 4 to the x. We're going to graph it here. Okay? Moving it to the right one did all of that. Alright, we chose 3 values of x that we thought were important, and they were 1, 0, and negative 1. If you put in 1, 4 to the first was 4. When we put 0 in, 4 to the 0 is 1, and 4 to the negative 1 is 1/4. Remember those 3 points we circled, highlighted, starred, or whatever in your notes? From here, we are going to do these 3 points. Let me ask you something else. Where is the horizontal asymptote? Did it move? No, horizontal asymptote is still at 0 because the origin is still on 0. It's on the line. So, we're going to go from the new origin over 1 up 4, from the new origin 0, 1, from the new origin negative 1, 1/4. Use the asymptote as your guide, and there is your function. Well, that was fun. We should try that again. That was some goofy stuff. You might have to rewind and rewatch some of these videos in this chapter. Alright, this one, our parent function was 4 to the x, but what's going on with this minus 1? Is it inside or outside of the function? It is outside the function. It is not in the exponent with the x. So when it's outside there, which direction does it move? Yeah, it moves down. Down 1. So I'm going to take my origin, and I'm going to move it down 1, and there's the new origin. Where is the horizontal asymptote now? It's at negative 1. Draw it in there. It's purty. Okay? Now I have my 3 points. My basic function is 4 to the x. And that's the one I'm putting these into because I have already taken care of that minus 1. So I'm going to use my 3 points. 4 to the first, 4 to the 0, 4 to the negative 1. And from this point, I'm going to graph those points. From there, using the horizontal asymptote, there's my graph. Ooh, that was fun. Let's do another one of those. Hit pause anytime, guys. Hit pause, hit pause. Look at this one, negative 4 to the x. The parent function is 4 to the x. But when I have a negative outside, what happens? Yeah, it's going to flip over the x-axis. So does my origin move? No, origin's still there. Where's the horizontal asymptote? Still at 0. Okay, all of that stayed. What I'm going to do though is I'm going to end up flipping. So when you were in Math 2, and you had to do that, we added another column where we flipped it. Okay, so let's try that out. My x's When I take 4 to the first, I get 4, but I'm going to flip it. When I take 0, I get 4 to the 0 is 1, but I'm going to flip it. And my negative 1 gives me 1/4, but I'm going to, you guessed it, flip it. Okay? So you can use a table to do that, or you can use the transformations. I'll show you what I mean. Don't worry about this column, because your X and Y is the first and the last. Okay? That might be something that you've forgotten about. Sometimes when I'm talking to people about that, they've forgotten how that worked. Alright, here we go. We're going to go here to 1/4 was where it used to be, but now it flipped. So this is graphing using the transformation, or the table, 1, -4. Now from here I'm going to go 0, 1, but I'm going to flip it. Now I'm at 0, 1, -0, -1. And then here I'm going to go -1, 1/4, and flip it. Now I'm at -1/4. Okay? So you can see how that works with the table and with just thinking through your transformations. This guy flipped over, he's going the other way. Alright. I like to call him old Loch Ness Monster. You know who the Loch Ness Monster is? Go look him up. You always see his head sticking up above the water. This is old Lockie upside down. He's fishing. Okay. We're gonna, let's see. This way. Do you remember last year taking some time to develop this number E? I know, that was a long, long time ago, right? Well, you have a special number E that we're going to be looking into a lot in this chapter. First, I want to show him to you on here. The number E is so special that he has 2 buttons. Let me get the buttons up here. First button is right here above the division. So I could just hit second division and I can see my number E in there. Or if I want to take E to a power, let's say I want to do E squared, I would use over here above the LN button. See E to the X? So I could do second LN, and then I could put in squared. And there's where you should be. Okay? Alright, now, let's give this a try. We are going to graph our function y equals e to the x. So our base is e, which is about 2.72. So when I do my 3 special points with e to the x, same thing's going to happen. I'm going to put in those same 3 points. So if I have e to the first, I get e. Don't talking right at the same time, right? E. If I take e to the 0, anything to the 0 is 1. And when I take e to the -1, gotta grab that special button, I get 0.38. E to the -1 is 0.38. So I still have a horizontal asymptote at 0. That didn't change. This is just my base changing to a special number. So from here I'm going to graph 1, 2.72, 0, 1, and -1.38. Still looks like somebody send lead. Goodness, it still looks like our same Loch Ness Monster, our exponential function. So I want to do one more graph of transformations with him. This one has 2 transformations. Do you see them? Our basic function was e to the x. That's the parent function, but I'm going to move it twice. First of all, you see the negative? That's our flip. And this +2 inside here, it's inside the function, so it is to the left 2. Okay. So I have to move my origin, and we're going to flip. When I moved my origin, where did the horizontal asymptote go? Yeah, that That was a trick question. It stayed. It's still at 0. I didn't go up or down. Okay? We're going to do our 3 basic points. And this time I'm going to add in a negative e to the x so that it will take care of the flip for us, okay? So, e to the 1, e to the 0, e to the negative 1. Flipping those guys. Flip. Yay. Don't worry about this column anymore. We're flipping. So from our new origin, go 1, and instead of going up, we're going to flip and go down to negative 2.72. 0, 1 becomes 0, negative 1. Negative 1, 0.38 becomes negative 1, negative 0.38. Old Lockie's taking a dip, looking for some fish. There he is. Yay. Alright, so now you can do the graphs with the transformations. Next part is a little algebra. We're going to do some solving, but I'm going to save that for part 3.